Hi grade 8s, welcome back to another one of our video lessons. So today we're going to continue with topic 10, which is construction of geometric figures on page 90. Alright, we're going to begin with constructing perpendicular lines. So before we do that, we need to learn how to draw lines accurately. So if I ask you to draw a line which is 6 centimeters long, I don't want you to go and measure 6 centimeters and then join the 2 points together. What I want you to do is draw a line which is longer than 6 centimeters, okay? And then place your ruler on it carefully and mark off the two end points, label it AB, and call it 6 centimeters, okay? You can even make a faint construction line and then join this in a darker line to show me that, yes, there's my AB, 6 centimeters, okay? So that technique just increases the accuracy of your line and you not making a mistake. Guys, remember this section requires precision because we have precision instruments. We're learning to draw precise triangles and angles and bisectors and so forth. Okay. All right, guys, so let's continue. So I'm going to start with constructing a perpendicular bisector. Okay. The word bisector means it's cutting something exactly in half. Perpendicular means 90 degrees. So if I say I want to construct a perpendicular bisector of A and B, it means that I want to cut A and B exactly in half at a 90-degree angle like that. Okay. So what's important for this section is that we're not going to be using protractors. Okay, you're not measuring angles. We are going to use compasses and techniques, geometric techniques, in order to do this. Okay, so first let's start with the perpendicular bisector. So we need to draw a line 6 centimeters. So what I'm going to do is I'm going to draw a faint line, measure 6 centimeters, and join it. Okay. That's my AB, 6 centimeters. Now, what I want you to do is take your compass, all right? And we're going to put the compass needle at A and we're going to open it up so that it's further than halfway. So it's somewhere between halfway and B. So we're going to open the compass to about here. And what you're going to do is you're going to make an arc over there and you're going to make an arc over there. Okay, I'll make it darker so you can see. Okay, so now keeping your compass at exactly the same length, what you're going to do is you're going to swap over. You're going to put your needle point at B, keep the same distance as you had before, and you're going to make an arc like that and like that. Okay, so now you've created these two crosses over there where the two arcs crossed and where two arcs crossed over here. So you're going to take your ruler and you're going to join these two lines like that, or these 2 points. All right. And that is known as a perpendicular bisector of A and B. Okay, so this is now 3 centimeters and this is 3 centimeters. Okay. Cool, guys, and that's as easy as that. Now, in a worked example on page 90, they take you through these steps. They also say that you could draw a whole circle around this point A and point B. But there's no point of that because all you need is this point and that point. So you literally just make an arc, swap it around, and do exactly the same. Okay, then construct the line going down, and you are done. All right, guys, let's look at exercise 10.1. So use the instructions below to construct these figures. Do all your constructions in pencil and show all construction lines. You may not use protractor in any of these constructions. It is a good idea to draw a rough sketch of each construction first so that you know how much space you'll need. Okay, guys, with these kinds of things that we're going to do, let's say this is your page, right? Don't start drawing your thing in the corner over here. So what you want to do is you want to have at least maybe half a page per drawing that you do. So you have space to work. Because when you need to draw circles, you need to make arcs above and below. So the thing might be only this big, but you need to draw an arc at the top and at the bottom. So if this is your page, I would divide it in half visually and then start my drawing over here. That's where my AB would be, so that I could mark off my crosses there, and have space to work with. Okay, so yes, you could do it roughly first to check, but as a rule of thumb, half a page per drawing is perfect. Okay. All right, guys, so what they want from number one, construct perpendicular bisector of AB if AB is 10 centimeters. All right, I'm going to show this to you again quickly. So I obviously don't have a ruler here, so I'm going to assume what it is, but you guys have rulers, and I am going to measure it when I'm marking this work. Okay, so we have AB. So remember, construction lines are faint lines. So what I do is I draw myself in the middle of my half a page, a faint line that's doing that. Then I put my ruler down and I measure 10 centimeters and I mark it off AB. And this is 10 centimeters. Cool. Next step, I take my compass. I put my needle point at A, open the compass closer to B or somewhere between halfway and B. So say over there, right? We open the compass, we make a mark over here. We swing it down, make a mark over there. Keep the same distance. You walk around and, well, you move your compass around. I walk around. So there I make a mark there. I make a mark there. Now what you do is you join this line with your ruler and we have a perpendicular bisector. Guys, I want you to put the little right angle sign over there to indicate that it's a perpendicular bisector. Okay. And also what you can do is you can put 5 centimeters to tell me that yes, it actually is halfway between. Okay. So that is 1 and 2. Guys, number 3 and 4, what I want you to do is to draw these two triangles. One is an acute triangle and the other one is an obtuse. Remember, obtuse is an angle that's greater than 90. So you're going to draw these two triangles. And then I want you to construct perpendicular bisectors of all the sides of the triangle. So for number 3 and 4, you want to have a lot of space to work. So do at least half a page. Okay. All right, guys, so you can do that for homework. Let's continue. So now we're going to continue, but we're going to have a little bit of a different application to this. So I'm going to give you a line and a point, and I say drop a perpendicular line from that point. Okay. Right, so a perpendicular line can be constructed at any point on the line. The construction is similar to the construction of the perpendicular bisector of a line, but you first need to construct arcs on either side of that point, which are equidistant from the point. Equidistant means that they are equal distances from the point. All right, so let's go through the worked example. It says construct line AB, which is 5 centimeters, and then construct an angle of 90 degrees at point A. So we want to make the 90-degree line not in between A and B, but exactly at point A. All right. So the idea is almost exactly the same, is that we just need to create two equidistant points. So they want 5 AB 5 centimeters. There's my faint line. I measure AB, draw a darker line, and that is 5 centimeters. Cool. Then they want us to do, well, they want us to draw, what do they say? Construct an angle of 90 degrees at point A. So here's point A. What they're saying is that first we need to create equidistant points around A. So what I'm going to do is I'm going to put my needle point at A. I'm going to open up my compass and make a little arc over there, not too far away from A. Just maybe, a few centimeters, 2-3 centimeters is fine. Okay, then I'm going to do the same, open up and make an arc over there. Now I'm going to take my needle compass and put it at each one of these points. So I'm going to put my needle compass in here. I'm going to open up the compass maybe further than this, maybe double this distance, triple the distance. It doesn't really matter. The point is that you want to make an arc and make another arc. Okay, so we put our needle point in here. We open up our compass. We make a mark over there. We flip it around, put the same distance into that point over there, the needle point over there, and we make another mark there. We also do one at the bottom, here and here, keeping the same distance on each side. Okay, so now what we do is we join the two crosses with a perpendicular line. And we can say that that's 90 degrees. Okay, the only difference here between this and the perpendicular bisector is that we had to create these equidistant points. Okay, if we are bisecting A and B, that's already equidistant from the point in the middle. So we already stuck our compass in here, made an arc. So basically we had those 2 points. Now we have an end point, and we have to create the 2 arcs on the sides to make it equidistant. Okay, guys, that's that worked example. And the next one that I'm going to do with you is dropping a perpendicular line from point P. Okay, so we have a line. So they say drop a perpendicular from P to the line AB. All construction lines must be shown. So we have a line that's doing this, and we call it AB. Okay, here they don't specify how big your line is. Okay, so you can make it however big you want. Guys, also, when I'm going through these worked examples in the geometry section, I want you to try this as I'm doing it, okay? You can pause the video, do the arc, unpause it, and carry on, okay? Don't just sit and watch me do it, because this is practice. You've got to get used to being precise with the compass and making sure that your distance is the same. Okay. Right, so we have line AB, we have a point P over here. P for point. Okay, now they want us to drop a perpendicular line going down. What we're going to do is we're going to put our needle compass into here. We're going to open it up to maybe somewhere over here to AB. And we're going to make an arc there. Or we could even carry on and make a half circle like that. Okay. Actually, that's a little bit skewed. Let me try that again. Okay, so if we open it up there, it will make a mark like that and like that. Okay, it's a little bit better. Put P there. All right, so you've opened up the compass, you've just made a mark there, you carried on, you made a mark there. Now, keeping your compass at exactly the same length, what you're going to do is you're going to put now the needle point into here, keeping it at the same distance, and we're going to make a mark like that. Now you're going to flip it around, you're going to put the needle point into that point, and keeping it the same distance, you're going to make another mark like that. Okay, now you're going to join dot P. Do they want to just, okay, so they want a PQ. So what we're going to do is we're going to join P and this point over there. This is 90 degrees, and they call that point Q, and this is C and D. All right, guys, that is how we do any perpendicular lines to each other. So remember, we had a bisector, then we could do it at a particular point where we had to create the 2 arcs on the sides, and we could drop a perpendicular line from point P. Okay, so those are pretty much all the variations we could have you dropping a perpendicular line anywhere. All right. Okay, so let's see what the exercises look like. So exercise 10.2, number 1 says CD equals 9 centimeters. Point E lies on CD, and CE equals 3 centimeters. Okay, guys, I'll start this off for you, and the rest I want you to do for homework. Okay, so CD equals to 9 centimeters, right? Point E lies on CD, and CE is 3 centimeters. So, guys, if you don't understand this straight away, read it a few times. Read it in bits, right? So read the first bit, draw your line CD. Then read the next bit and understand, what are they saying? Oh, they're saying point E is on CD, so it's somewhere on the line. And then they say CE is 3 centimeters away. So what does that mean? We have CD, okay, and they say that is 9 centimeters. And they say E is on CD, and it is 3 centimeters away, like that. Okay. So they say state the ratio of CE to ED in its simplest form. Construct a right angle at E. All right, so that's the drawing. They want us to construct a right angle at the point. Okay, remember what we need to do from the previous examples. If we're doing it at a particular point, we need to create equidistant points, make the two arcs, and join it. Okay. So state the ratio of CE to ED. Well, that we're going to measure. So CE is 3 centimeters. ED is 9 minus 3 gives me 6. What's the simplified version of that? Well, divide both sides by 3. Divide by 3, we get 1. Divide by 3, we get 2. So it's 1 to 2. Yes, this is 3 centimeters. This is 6 centimeters. Okay. Guys, so that's pretty straightforward. Number 2, construct line PQ equals to 14 centimeters. Place point R on PQ so that PR is 5 centimeters. And then construct a bunch of perpendicular things. Guys, it's pretty much the same as number 1. It's just asking you for different constructions. Not at a point, but now we want to do it dropping it from point R. All right. Number 3, construct angle ABC, which is 26 centimeters, with AB equals to BC, which is 15 centimeters. Draw AC. Okay, so guys, construct that angle. So 26 degrees, here you can use your protractor. Remember, we can't use protractors for constructions, but if they say construct an angle, then it's okay. They say AB and BC is 15 centimeters. All right. Guys, I want you to work through this exercise, see how far you get, and we can talk about it in our Skype session. So in the next lesson, we're going to continue with constructing angles. I'll show you how the protractors work and how we're going to use them. And we'll probably get through exercise 10.3, some worked examples, and maybe 10.4 and 5 will be for homework. Okay, guys, so I hope you enjoyed the lesson, and I'll see you next time.